Alright, so tomorrow we'll be doing a titration, and this is our note to kind of help explain titrations. So we use titrations to determine the concentration of a known volume of a solution. We use these things called pipettes and burettes to do this. For example, you could use a 0.1 known concentration of sodium hydroxide solution to find the unknown concentration of a hydrochloric acid solution. So when using phenolphthalein as an indicator, you put the acid in the Erlenmeyer flask. So what you have down here is you have your known sample, and by known, it's a known, sorry, I forgot to add that in, it's a known volume, and it is our sample of the acid with unknown, sorry if my writing's messy, unknown concentration. Sorry about that. So it's a known volume sample of an acid with an unknown concentration. So I could give you an unknown. What you're going to also add in here is you're going to add 2 drops of indicator. We'll use phenolphthalein tomorrow, but that would be our indicator we'll use. What you're then going to do is in your burette, what you're going to have, this thing right here is called a burette. I'll have them out tomorrow. This thing here is a burette clamp. They are special clamps we'll have out. And then inside the burette, you're going to have a base of known concentration. What you will do is you will add the base to your acid. So what you're going to do is you'll add the base from here, and you'll slowly add it into your solution. As you go along, what will happen is initially the pink color will go away quickly, and then slowly it'll go away slower and slower. And eventually you'll add one last drop, and then this whole bottom of the Erlenmeyer flask will turn a very, very light pink. The lighter the pink, the better. And then you've reached your end point. So the reaction taking place inside the Erlenmeyer flask is going to be an acid plus a base, and it will react to form an ionic salt. And water. In my example from above, it would be hydrochloric acid, sorry if that's messy, plus sodium hydroxide, and it will react to form sodium chloride that will be dissolved in a solution, so it will be aqueous, and water. At first, when the sodium hydroxide is added, there is an excess of hydrochloric acid, or an excess of hydrogen ions, or hydronium ions. So the solution will remain acidic, and the phenolphthalein stays colorless. Finally, when you get to something called the equivalence point, EQUIVALENCE point, this is when the base has completely neutralized with the acid. There is no acid or base left in the solution, only H2O and the ionic salt. This would be the moment where you have a perfect balance of hydronium and hydroxide ions. The very next drop of sodium hydroxide that is added will cause the indicator to turn purple. This signifies the end point of the titration. So you'll be in excess by exactly 1 drop. So once you do this, you could calculate the concentration of the acid using stoichiometry. So the first thing you would do is you would measure out your volume of hydrochloric acid. So let's hypothetically say I measured out 10 milliliters of my hydrochloric acid. My first try, and you're going to end up doing a variety of tries. So this is going to take you a number of tries to kind of do this. It's not just going to be to do this, but the other thing you're going to do is on the sides of the burette. So if this is your burette here, you're going to have all these sides. So you're going to want to write down your initial volume, and that's going to be your volume 1. And then you're going to want to write down your final volume, which is going to be your volume 2. The crazy thing about the numbers is if you have your liquid up to the top here, the number up here might be something like 2. And then that'll be 5, and the numbers will go down as you proceed. So what will happen is you will start off at something like, perhaps I start off at 1.40 milliliters, and they are very precise. You can measure with very good accuracy with these burettes. They are precise. And then if I keep adding the base into the solution, and then I finally put in my last final drop, the solution turns purple, and then I measure, I would then notice that my new number is going to be 11.80 milliliters. So what you need to do is find the volume of NaOH you added to reach that. So you're going to say, or use your second volume and subtract from the first volume. And you can also start this volume out at 0 to make your life easier if you wanted to, but you can just kind of continue forward. And that's going to equal about, or not about, it's going to equal exactly 10.40 milliliters. So I added exactly 10.40 milliliters. So now I have a known volume and a known concentration to neutralize a known volume but unknown concentration of hydrochloric acid. The concentration of NaOH in the solution, therefore, is going to be the concentration of this solution, I tell you at the start of the lab, you don't have to do math to do this, is 0.100 molar NaOH. So you will end up measuring this by how much you add. You'll have this from the side of the container. This you will measure, and you need to find the concentration of the hydrochloric acid. So then what you're going to do is you're going to do some math. So these numbers are going to move forward with us, okay? So just make sure that on your sheet, you kind of look at your sheet. I'm going to now lose this data when I flip to the next slide. So I'm just looking at my sheet, which is just above. So the step 1, I'm going to take what I'm given and change it to moles. So moles equals concentration times volume, which equals 0.1 mole per liter. I got that from my concentration of NaOH. And sorry, I just need to scribble out this here. This should be calculate the number of moles of NaOH, sorry about that, in the burette. Sorry about that. So we're going to find the moles of the NaOH. So the first thing I do is I take the 0.1 moles per liter, which is written on the side of the container that you're going to get your solution from. I'm going to multiply it by the volume in liters. So I convert my 10.40 milliliters to liters to get 0.0104 liters. If I take 0.01 and multiply it, I'm going to get 1.04 times 10 to the negative 3 mole. And sorry, I've run out of room here. And that's of my NaOH solution. So that is my amount in moles that I had to add. So now I need to use mole ratio. The nice thing about this reaction is it's a 1-to-1 reaction. So for every 1 hydrochloric acid, you're going to need 1 mole of NaOH. So you're going to take 1.040 times 10 to the negative 3 mole, multiply using your chemical reaction. For every 1 mole of HCl, you're going to need 1 mole of NaOH. And don't forget that these are the coefficients here from my chemical equation. And that's going to equal, so these are going to cancel out. That's my mole of NaOH. And that's going to get 1.040 times 10 to the negative 3 mole. So, step 3, do the calculations to calculate the concentration of HCl. So, concentration equals moles divided by volume. I have my moles right here, and your volume is the volume from the Erlenmeyer flask that you had at the very start. So that's going to be 1.040 times 10 to the negative 3 mole of HCl divided by the volume of 0.010 liters. That's the volume that I measured at the very, very start. And my concentration is going to be 0.104 molar. I don't have enough room on the side there to write moles per liter. And that's your final concentration. Alright guys, this is practice time. So what I'm going to suggest to the supply teacher is right now you press pause and let everybody try to do example 1. Then press play and I will walk through example 1, which is right here. And then press pause, let everybody try example 2. Then press play and let them watch me do example 2. That would be my recommendation right now. So please press pause now. Welcome back. I don't know if you actually pressed pause, but I hope you did. So the first thing you need to do is write out your balanced chemical equation. So I've got NaOH plus HCl reacts to form. In a neutralization reaction, the hydrogen goes with the hydroxide to form H2O and an ionic salt. That will be NaCl. It's the exact same reaction we just did. Our coefficients will be 1, 1, 1, 1, and that's everything balanced. The next thing is I read and I see that this volume of hydrochloric acid just neutralizes this volume and that concentration of sodium hydroxide. So I don't know my concentration of hydrochloric acid. So what I will do now is I'll take 0.1000 mole per liter, multiply it by 0.025 liters. Don't forget, you cannot do this math with milliliters. You must convert your milliliters to liters. And that's going to equal 2.500, don't forget significant digits, times 10 to the negative 3 mole of NaOH. You can usually fit this in a little bit better on the sheet when I handwrite it, because I'm writing gigantic right now. Now I'm going to apply mole ratio. So I then look at my coefficients and I see it's 1 to 1. Still just do this out of practice, so it's going to be 2.500 times 10 to the negative 3 mole of NaOH times 1 mole of, and I'm sorry if this is super messy, HCl for every 1 mole of NaOH. These cancel out, producing 2.500 times 10 to the negative 3, pen's not writing the negative sign, there we go, mole of HCl. Now the final step is to convert this right here, or not convert, but to now determine the concentration. So C equals N over V. I'm just going to kind of squish this in right here, so I'm sorry about that, but C equals N over V, which equals 2.500 times 10 to the negative 3 mole divided by my volume, and my volume is right up here. So I take 13.84 milliliters and I convert that to liters to get 0.01384 liters. And the grand finale, the concentration of my unknown acid, when I punch in my calculator, is 0.1806 molar. And then you would then write your answer with proper significant digits, and I believe if you look above, I used 4 significant digits in all my question, so that's what you're going to have to write your answer as. Please press pause now, so that way you can try to do the second question on your own. And welcome back. So this time it's H2SO4 plus, and I know it's aqueous, I know I'm not writing subscripts, but it's just to save time, and I'm sorry about that, plus KOH reacts to form K2SO4 plus H2O. And I know some of you might be crying because you're watching me not write subscripts, so I'll just try to be a good teacher for a second. And that's liquid. That's aqueous. That's aqueous. And that's aqueous. All right, now we balance it to get 2, 1, 1, 2, and I believe that balances. So now you no longer have a 1-to-1 mole ratio. Take 1 second and look at your question again. You've got that amount of sulfuric acid in moles. You do not know the volume. You have this volume and that moles. So now you can find the volume needed to react completely. So start out with what you have. And what I would do is I would convert the concentration and volume of potassium hydroxide to moles. So let's do that. So we take our 0.650 mole per liter and multiply by 0.0372 liters to get 0.02418 moles. And that's of KOH. To clean this up, I'm now going to erase my work from before. It's probably going to disappear off my screen. Do not panic if some of my work disappears. I'm just going to try to clean this up to see what I can do. They changed the eraser on me. They have. Okay, so I'm not able to even erase. Amazing. So what I'll have to do then is I'll just do this. Sorry. Let's see if it lets me erase now. Nope. No eraser. Awesome. So now I'll take 0.02418 mole of KOH and apply mole ratio. I want to get rid of KOH, so I look up above and I see that the coefficient I'm going to need to use for this one is for every 2 mole of KOH, 1 mole of H2SO4 is needed. Where did I get 1 mole from? It's from right here. These cancel out. I take that with my calculator and I punch it in to get a grand total of 0.01209 mole of H2SO4. So now for the finale, I know that volume equals moles over concentration, which equals my moles is 0.01209 mole, and I can divide that by my concentration from above, and the concentration is given right here in the question. So that is 0.0. Oh no, not a 0. Sorry about that. Let's see if I can undo that. Ooh, I can. 0.250 mole per liter, and by unit analysis, my moles cancel out. And when I punch that in my calculator, the volume I would need to use would be 0.048 0.836 liters, or you can even turn that into milliliters. Please take a second and look and think, how many significant digits do I need to list my answer at? Yes, it's 3. So then I say equals 0.0, so therefore 0.0484 liters are needed. You could change that to milliliters and say 48.4 milliliters are needed. And that is the note.